Last section we're going to look at this week is 4.3, okay, with law of cosines. There are no special cases like with law of sines where you can get the 0, the 1, or 2 solutions. So I think we'll be able to do law of cosines in one class. So let's make a table just to review what kinds of problems we do law of sines and what kind of problems we're going to use for law of cosines. I'll show you law of cosines in a second. Law of sines. Can somebody give me one type of triangle that we solve with law of sines? And I'm thinking of like the A and the S's. Yep. What is that? SSA. Now that's the one that's the tricky case. Remember, you can end up with 0, 1, or 2 solutions. That's the only case you ever have to worry about that. What's another case for law of sines? Pete?
SAS?
We're going to talk about SAS today.
Oh.
SAS is going to fall under law of cosines.
ASA?
ASA, yep, that was one. And that's nice and easy, you only have one solution. Jenny? AAS, yeah. So those are the 3 cases that we can use for law of sines. For law of cosines, we're going to have 2. Pete said one of them, that's SAS. And you might think, what's the difference between that and something like SSA? They both have 2 sides and an angle. 2 sides and an angle. But the difference is, where is the angle? Is the angle between the 2 sides? Is it not between the 2 sides? And that makes a big difference which law you use. So SAS. And the other one we're going to look at is side, side, side. That's when you're given all 3 sides. Okay. So those are the 5 types. You might notice there's no angle, angle, angle up there. There's a reason for that. Why couldn't you solve a triangle if I told you all the angles? Like, let's say it was an equilateral. I'll tell you the angles are 60, 60, 60. Why can't you tell me the side lengths? Okay. Angie?
Because no matter what the side lengths are, the angles are the same.
Yeah, you could have lots of problems that are equilateral triangles. Maybe the sides are 2, 2, and 2, or 20, 20, and 20, or 30, 30, and 30. You don't know. Every problem you solve has to have at least one side in it. Sometimes 2, sometimes all 3. But you'll never have a problem without an S in it. Other question on that? Okay. So, let's look at this one. Okay, I'm not going to go through and solve this one yet. But does anyone remember when we do law of sines, I always say to look for this row. It's like the most important row. And what are you looking for? Yep.
A row with everything in it.
A row with everything in it. Does this have a row with everything in it? No. And you don't have a way of finding a row with everything in it. If you're thinking, oh, could I just do Pythagorean theorem to get C? No. If you do Pythagorean theorem, you're assuming you have a 90-degree angle, and you don't. So we don't have a row with everything in it. So here's the problem. With law of sines, you need to pick 2 rows in your table. And out of the 2 rows you pick, you can only be missing one thing. The other 3 you have to know. Well, let's say you pick the first 2 rows, and you try to use those for law of sines. That's no good. You're missing 2 things. Can't be missing 2. You'll be missing 1. So let's say you try the last 2 rows. Okay, same problem. You're missing beta, and you're missing C. Can't do it. So the only other thing you could try is, well, what if I use the first row and the last row? No. The first row you're missing alpha, and the last row you're missing C. So no matter which 2 rows you pick, you always have 2 variables in your proportion. That's not going to work with law of sines. Maybe we'll come back and solve that one after. I don't know. So what we have instead of law of sines is law of cosines. Okay, so I already explained to you earlier that law of cosines is used when you want to solve a side angle side or side side side. Side 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 I think is the easiest one to tell without a picture, because you can just look at the information and they'll tell you A, B, and C, and you know it's side side side. When you have two sides at an angle, that can be a little tricky. Usually you have to draw it and figure out where the angle is. Is it between the sides, which it will be today, or is it not between the sides? And that's what we did yesterday. And there's a sketch on the left of a side angle side, and a sketch on the right of a side side side. Now, side angle side is always solvable. Never have to worry about a no solution there. And the side 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 problems that I give you will also always be solvable. There are side 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 problems that aren't solvable, but we're not going to do them. The way a side 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 problem could be unsolvable, think in a triangle, when you add two sides together, they have to be bigger than the third. So if I gave you sides in a triangle of like 1, 2, and 300, there's no way you're going to be able to connect those sides to make a triangle. Think about this side that's 300 units long. Okay? It's like that. And then you've got these two little sides on the ends. There's no way that they're ever going to meet. Okay? So again, I want to see if you can actually solve side, side, side. So I would never give you one that you can't on the test. Right. So in the formula, we're going to use the same variables that we used for law of sines. A, B, and C will be your sides. Alpha, beta, and gamma will be your angles. Now, I'm going to start to write it, and I think you're going to recognize what the beginning of this formula looks like. That's not the whole thing, but that's part of it. C squared equals A squared plus B squared. What's that? Yep. That's the Pythagorean theorem. So the law of cosines is basically the Pythagorean theorem, but with an adjustment at the end. And the adjustment lets you use this formula when you don't have a right angle. Remember, Pythagorean theorem is only if you have a right angle. Okay? So it's like the Pythagorean theorem, but there's an adjustment. And that is what we adjust by. So it's C squared equals A squared plus B squared minus 2AB cosine gamma. Now, let me read that in a little bit different way, because we can write this formula three different ways. We can start with C, we can start with B, or we can start with A, but it's the same pattern. One letter squared equals the sum of the other two letters squared minus twice the other two letters you just used right before it times the cosine of the angle across from the letter you started with. That's the pattern. So let's see if we can get this one. B squared equals, what do you think would come after the B squared? Just the first two things. Yeah?
C squared plus A squared.
Yeah, and I'm just going to put that in alphabetical order. A squared plus C squared minus, and what do you think would come right after that? Yep.
2AC.
2AC times the cosine of, what angle do we think is under that, Lacey?
Beta.
Beta, the angle across from the letter you started with. That's not a different formula, that's the same formula. You could write this an infinite number of ways if you let your sides be x, y, and z. X squared equals y squared plus z squared. You could do it that way. But these are the most common letters we'll use, so I'm just writing it the three ways that you'll most likely see it. And let's do this last one. Right. A squared would equal, Ava, what do you think would come next?
B squared plus C squared.
Yep, B squared plus C squared. Can you keep going with it?
And then 2
can't think of the name of it, but it's the one that goes with A.
What's the one that goes with A? Done? Alpha. And it's great, to memorize all three of those, but really it's more important to understand the pattern, especially in a word problem where maybe nothing is going to be labeled for you. Or maybe they're going to not use A, B, and C for the signs. Maybe they're going to use X, Y, and Z. It doesn't matter what you call them. As long as you understand the pattern of what you're supposed to do, you can call the letters and sides anything you want. Okay. Any questions on those? That's the law of cosines. Now, when we did law of sines, we went through the proof about y. This one's not that hard to prove, but the problem is it requires something I haven't taught you. It's called a trig identity. So without that, we can't easily, I don't think we can prove it at all. So we'll skip going over the proof. Okay. And as far as the notes, that's pretty much it. Just look at some examples. I think this is the first one I had up on the board. A is 2, B is 3, gamma is 60. Yep, it's the first one I put up. So, two ways we can try to figure out what law we should use. 1, make a sketch. 2, look at the table. Either way. If you don't have a full row, you cannot use law of sines. Now in the test, I'm not going to tell you, okay, use law of sines on this problem. You have to figure that out. Okay. So let's make a sketch of this one just so we can see it. Okay, so we have A, B, and gamma. Put A at the bottom. And across from A, actually I can fill that in. So A is 2. Alpha goes across from it, and I don't know it. B is 3. Beta goes across from it, but I don't know that either. And C I don't know, but gamma is 60. All right, so looking at the, again, that's not to scale at all. But looking at that information, what kind of triangle is that? Ava?
Side angle side.
Yep, that's a side angle side. You've never had a problem like that up until now. We've never had two sides and the angle between them because we couldn't do it. But now we can. So what we have to do is figure out which version we're going to use. We can call this version 1, 2, and 3. So we can go back and look at what we have. We have A, we have B, and we have gamma. Whatever version you plug into, you can only be missing one thing. If you plug into a version and there's two things you don't know, then one of two things. You either shouldn't be using law of sines, you should be using law of sines instead, or you picked the wrong version. Lacey?
So would you use number 1?
Yeah, we're going to have to use version number 1. Every version has every side. A, B, C, A, B, C, A, B, C. If you go to our problem, we're already missing C. So we're already missing a side. You can't be missing anything else. So let's go into version 1. And that one starts off as C squared. Sometimes what I do is I just write it down. So then I don't have to try to think of the formula at the same time I'm plugging into it. I wrote the formula. Okay, that's done. Now I'll plug into it. So C squared equals, and James, what's A squared in this case?
2 squared is 4.
4 plus
9.
B squared, yep, is 9, minus 2 times A times B. Autumn, what's 2 times A?
4.
4 times 3.
12.
12. So that's 2 times 2 times 3 times the cosine of, Jess, what's gamma in this case?
60 degrees.
60 degrees. Okay. Now, this is more about order of operations than it is about getting the variable alone. The variable is pretty much already alone. I mean, you're going to have to get rid of this exponent of 2 at the end. But other than that, the variable is by itself. So now we're going to do this arithmetic on the right-hand side. So c squared equals. Okay, when we do order of operations, what should we do first on the right-hand side? Tom?
The cosine 60.
Yeah, you always handle your trig function first, right? Cosine of 60. So let's do that. Okay, and the cosine of 60 is going to give me 1/2. 0.5. All right. Now, what would I do next on the right-hand side? I have 4 plus 9 minus 12 times 1/2. Yep.
Multiply negative 12 by half.
Yep, we're going to multiply the 12 times 1/2, and that's going to be a minus 6. Any questions on that? Yep.
How did she get the 12?
The 12? So the 12 is this. 2 times A times B. 2 times 2 times 3. Now, add and subtract, just go in order from left to right. About Jacob, what's 4 plus 9?
13.
13 minus 6?
7.
7. Okay, so we've done all the arithmetic we can do. Now I need to get C by itself. So what do I do on both sides? And it doesn't involve adding or subtracting or multiplying. Squaring is a function, so you have to cancel it with the opposite of that function. Yep.
Square root.
Square root. That's the inverse of squaring. Square root. That's gone. And that's our answer. These are going to be rounded off to 3 decimal places, just like before. So let's do square root of 7. All right, so that's about 2.646. Okay, that rounds up. Okay, now 2.646. Let's fill that in on our diagram and see what we have now. This is 2.646. So this triangle was side angle side, and it still is. But I have a little bit more information. What other type of triangle is it now, besides side angle side? Yep.
Side.
It is side, 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 because I do know all 3 sides. And what does side, side, side fall under? Is that law of sines or law of cosines?
All cosine.
That's law of cosines. So if we were thinking to look at this as now a side, side, side problem, we would use law of cosines again. What other kind of problem is it? It does fall under one more type that we talked about now.
Side angle.
It does fall under side, side angle. You can look at that a couple ways. Here's a side, here's an angle that's not between them. So it is side, side angle. And Aiden, what formula does side, side angle fall under?
Law of sines.
That's law of sines. That's what we did yesterday. But what don't we like about side, side angle? I wouldn't try to do this problem like side, side angle, because what did we talk about with that yesterday?
If we found C, it could potentially mess up the other ones if we got C wrong.
And what's specifically annoying about side, side angle? Vivian?
You can have either 0, 1, or 2 solutions.
Right. If you try to approach this problem now as a side, side angle, thinking of it that way, you got to go through all that 2 solution, no solution stuff. Right? We don't want to have to do that. So when we start a problem with law of cosines, that's how we'll finish it. We're not going to switch over to law of sines. I'm not saying you can't if you're careful, but there's more chances for you to make a mistake. So let's do law of cosines one more time to get either alpha or beta. And I say just one more time because once we have two of these angles, we can just add them together and get the third one. So it doesn't matter which one we do. So how about Dominic, which one you want to try to find, alpha or beta?
Beta.
Beta. So we're going to find beta. All right, first step is write down the law of cosines that has beta in it. That starts out with b squared. Okay, so we're going to use version 2. I'll just copy it over. All right. So b squared equals a squared plus c squared, 2ac cosine beta. Okay, let's fill it in. All right, let's start with b squared. Jody, what's b squared in this case?
9.
9 equals. How about Olivia? What's a squared?
16.
What's a?
Oh, 4.
4. Okay, a is 2, so when we square it, we get 4. Plus c squared. Now, to get c squared, don't take 2.646 and square it. We already know what c squared is from the step above. What was c squared equal to? Yeah, 7. Right, if you take this and square it, you're going to get like 6.999. Why bother doing that? C squared was equal to 7. Minus 2 times a times c. All right, 2 times a, that's 4. Now I need 4 times c. I need a calculator at this point. So 4 times 2.646. That's 10.584. So this part comes out to 10.584. 2 times a times c. Yes, we did have to use what we calculated for c. There's no way around it. So that means if you got c wrong, unfortunately it's going to mess up beta as well. All right, now cosine beta. Now this one is pretty much the opposite of the last one. Okay, the last one we pretty much had the variable by itself. This one, the variable is definitely not by itself. There's a lot of stuff on this side, and everything needs to go to the other side. All right. If there's any like terms, we might as well combine those first. Do I have any like terms on the right side? Tom?
4, 7, and negative 10.584.
Let me write that equation a little differently. What is it? 9 equals 4 plus 7 minus 10 times something I don't know. That equation is pretty much the same thing. What are your like terms in that one?
4 and 7.
Just the 4 and the 7. Okay, that 10 is not considered a like term because it's being multiplied by a variable we don't know. Same thing's happening here. The negative 10 is being multiplied by something we don't know. So it's not a like term. And when we add 4 and 7, that gives me 11. Okay. So now, again, this is a step that sometimes people make a mistake on. Whatever you would do in that equation I just wrote up there is exactly the same thing you would do in this equation right here. So what do you think your next step would be? To continue getting beta by itself. Yes, subtract 11 from both sides. You cannot do 11 minus 10 any more than you can do 11 minus 10 here. Those aren't like terms. But you can take the 11 and put it on the other side. All right, so let's subtract the 11. 9 minus 11 is going to give me 2 times cosine beta. Now, my goal is to get cosine beta by itself. So what would be my next step to get rid of this negative 10.584? What's that? Yes, 9 minus 11 is negative 2. Thank you. That would mess things up a lot. So go ahead, Pete. What were you going to say about?
I was going to say it was -2.
Oh, negative 2. You caught my mistake. Nice. Good job.
So you're paying attention, doing great.
Yes. Yeah.
By negative 10.584 from both sides.
Yes, you're going to divide by negative 10.584. Again, I don't care what this comes out to right now. I'm not going to take my calculator and type in negative 2 divided by negative 10. I don't want to know what that is. I'm just going to leave it like that. But I can cancel these negatives. Let's copy it down one more time. Okay, so 2 divided by 10.584, and then we've got, let's see, this is all gone. So now we just have cosine beta. So now there's one thing left we have to do to get beta by itself. What are we going to do here to get rid of cosine? Lacey?
Would you do the inverse cosine?
Yep, we're going to do the inverse cosine on each side. You do it on the left, and we're going to do it on the right. Those cancel out, and there's your answer for beta. We're going to type that in and round it off. Now, before you type it in, look at the fraction right here. If the number in the bottom is bigger, you're good. If the number at the top is bigger, don't even bother typing it in. It's not going to work. All right, it means you made a mistake. So the number in the bottom should always be bigger. It won't work if it's not. So go back and check. All right, so inverse cosine of 2 divided by 10.584. So we get an angle, when we're solving for beta, is 79.108. If you can't see it, it's going to round up. 79.108. And now my last step is to get alpha, but that one's going to be quick. How can I get alpha? Yep.
Beta and gamma.
All right, so let's just add beta and gamma. All right, so I get 60 plus 79.108. And what do you want to do with that? Yep. Subtract that from 180. So if I subtract it, I get 40.892. And that's a law of cosines problem. That covers everything you would have to do. There's really two different things. Sometimes you have to solve for a side. Sometimes you have to solve for an angle. In a side angle side problem, you have to do both. You're solving for a side one time and an angle one time. In a side-side-side problem, you're never solving for a side. You only have to solve for the angle. Okay. Now, we have all three sides. So which angle do you think I have to find first? Yeah.
Doesn't matter.
It doesn't matter. This problem, in terms of if you mess something up, will it affect something else? No. you could find every single angle separate here if you did law of cosines 3 times. And you're never going to use what you find to find anything else. Okay? I'm not going to do it 3 times. I'm probably only going to do law of cosines 2 times. And as long as I get those 2 right, then I can add it up and subtract from 180. If I got one wrong, then that's going to mess it up. Okay? But let's see, what did we solve for the angle last time? We did beta. So let's do alpha. Let's do alpha and gamma. Okay, we'll go through alpha together, and then I'll give you a minute to try to set up the equation for gamma. All right. So let's write down a squared equals b squared plus c squared minus 2bc cosine alpha. All right, and let's start filling it in. So Katrina, what's a squared?
16.
So 16 equals. Okay. And then what's b squared? Yeah, b to the, what is b to the second power? 9 plus c squared. Jaden, what's c squared? Or just start with c. What's c in this case, Jaden? What's c? 6, and what do you get if you square that?
36.
36, yeah. Okay, minus 2bc. Raymond, what's, let's see, 2 times b. What's 2 times b? 6 times c? So final answer?
36.
36. Cosine alpha. All right, let's see, 36 minus 36. Can I just cancel that out? Make it 0? You think, Jacob?
No.
No, those aren't like terms. This is like 9 plus 36 minus 36x. That 36 is being multiplied by a variable. All right. But the 9 and the 36, we can add those up. And Lacey, what do I get if I add 9 and 36?
45.
45. All right, so I got that. How about James? What would I do next?
Find the cosine of alpha. Or
Well, my goal is to find alpha, but I got about
Yeah,
4 steps before I get there. Maybe 3.
I don't know.
Jake?
When you subtract, when you do the subtraction on the right side, the 45 minus, 36.
So what if you had this? 16 equals 45 minus 36x. Would you do 45 minus 36?
Oh, you have to subtract 45 from both sides.
You have to subtract 45 from both sides. You cannot do 45 minus 36 for the same reason you can't here. It's exactly the same idea. So you got to minus the 45. And minus 45. So that's going to give me 16 minus 45, which is negative 29. Okay, so now there's only 2 things left on the right that we don't want. What's the next thing I can do to get rid of one of those things? Yep.
Divide negative 36 on this side.
Good. Divide by negative 36. And I can already see I'm going to have a bigger number in the bottom of the fraction. That always needs to happen. And it did here. So negative 36 is gone. Negatives are gone. And what am I going to do on both sides to get alpha by itself? Yeah,
Inverse cosine.
inverse cosine. Okay, and there's your answer for alpha. So inverse cosine of 29 over 36. And we get an angle of 36.336. All right, 36.336. Now you've got more information. It was a side, side, side. You could think of this problem as law of sines, but it's going to end up being the case you don't want to deal with. So let's finish it by doing law of cosines one more time. And again, if you made a mistake on alpha, you'd get alpha wrong, but it's not going to have any effect on the next one we solve, because we're not going to use this. Okay. So I think we did beta, so I said let's try gamma. Let me just write it down. And again, I'm going to give you guys a minute to fill it in. Is that right? C squared, A squared, B squared. Yep, looks right. Okay, so see if you can set up your equation to find gamma. Even if you don't have a calculator, we'll do that part together. Yeah.
Can you just go up real quick?
Like right up to here?
Yeah.
I think it was 36,336, wasn't it? Yeah, 36,336.
Okay, thank you.
Yep. Now, without even doing anything, I'm expecting this angle to be bigger than 36 because it's going to be across from the biggest side. So if it comes out smaller than 36, something's definitely wrong. All right, so hopefully that, in a couple minutes, to at least just try to set it up, and then let's go through it and see if we can get the answer. All right, let's start out with c squared. Colby, what's c squared in this case? 36. 36, yep, I agree. And Autumn, a squared? Yeah.
Oh, 16.
Let's see, 16 looks good. And b squared, done.
Nine.
Let's see, 9 looks good. Minus 2 times a times b. 2 times a, that's 2 times 4 is 8. 8 times 3 gives me 24. So 24 cosine gamma. And Jody, what can I do on the right-hand side? What can I combine?
16 and 9.
Yep, just the 16 and the 9. And what does that give me?
Sorry,
25. So 25 minus 24 cosine gamma. Jess, my next step.
So you're going to subtract 25 from both sides.
Yep. Minus 25. That's gone. 36 minus 25 is going to give me 11. Looks good. And 2 steps left. We could do both at the same time. If you're not comfortable, you could do one at a time. Vivian, what's my next step?
You're going to divide both sides by negative 24.
So I divide by negative 24. And what would be my last step?
I guess you just have to. You just have to calculate it out.
We do, but we don't want to type in 11 divided by negative 24. That's not the answer. We have to plug that into something.
Yeah, take the negative cosine.
take the what?
The inverse cosine.
Take the inverse cosine. So we have to get rid of that cosine on the right, and we're going to do that by using inverse cosine. And there's our answer. So second, inverse cosine, negative 11 divided by 24. And if you wonder why I put the negative in the top versus the bottom, it doesn't matter. Just make sure you put the negative somewhere. All right, that's 117 points. That's going to round up to 280. Now, beta, that's the easy one. We already have two of the angles. Just add them up and subtract from 180. So I've got that. 180 minus that answer is 26.384. So this problem doesn't involve ever finding a side. Right? So all you have to do this time is find angles, which means you're going to use inverse cosine. When you're finding a side, you don't use inverse cosine. Okay. Questions on that? All right. Last one. So, what this problem is going to be, it's about measuring the distance between 2 points in front of you. And you might say, well, why don't you just measure the distance between the 2 points with a tape measure? Well, maybe you're standing somewhere, like on a bridge, or something, and there's like Grand Canyon's in front of you, like in the distance. And you want to try to measure the distance across the canyon, like a mile in front of you. Because you're planning to take your motorcycle and you're going to try to jump the canyon. So you got to see how far it is. All right, so but the point is, it's not easy to just take a tape measure and measure across the canyon. Okay, I don't advise that you do that. That's probably dangerous. So we're going to measure the distance between 2 points in front of us. But what we need to be able to do is to measure the angle. Like if I wanted to measure the distance from Jaden over to Angie, I could do that and pretend like there's a canyon in the middle of this room and I can't measure across. I would have to know the angle from where I'm standing to them, right? So maybe it's a certain angle. Well, this is the angle. If you were standing at a point and you pointed a laser at one target and a laser at the other target, it would be the angle between the two lasers. Then, again, maybe there's something in the middle, but I can walk over to one person and I can measure the distance there, and I can walk over to the other person and measure the distance there. So the surveyor does that. They measure the distance over to one point as 50 feet, and then they measure the distance to the other point as 70 feet. We want to find out how far apart the two houses are, or the example I gave, the two people in the classroom. And the reason that the surveyor can't just measure between the two directly is because there's some dangerous creatures. First of all, there's poisonous tree frogs. Those will get you. There's crabs, so they, the crab will bite you and stuff. And then the Easter bunny.
I was scared of the Easter bunny growing up, and so this day I still am, so that's why I like it.
So we don't want to try to walk between those two houses. We don't know what's out there.
Crayon.
So we're going to be able to get the distance by using trig. Trig is nice and safe, keeps everybody alive. That's what we want.
You say crayon.
And I didn't have a picture of a surveyor, but I had a World War II trench soldier. So I got that guy. And he looks serious. He looks like he could handle the Easter bunny, but we're still going to use the trig. All right.
How's that look like?
So first thing we need in the picture, we've got the two houses. Okay, we've got house A and house B, and the surveyor measures the angle between the two houses, and the surveyor is standing at point C. Okay, so here's how you draw your angle. You draw a line to A and to B. That's angle ACB. And it says angle ACB is 70 degrees. Fill in 70. Next, we know the distance to each house. Okay, that's safe to walk over here. Okay, we can walk over to house A. We don't have to walk through any of the crazy stuff. So, what does it say? The surveyor walks the distance between houses A and B and finds the distance to be 50 and 70. All right, so this distance is 50. This distance is 70. And the question is, what is the distance between the two houses? Okay, so looking at the information we're given, what kind of triangle is that? Yeah?
Side angle side.
That's side angle side. That falls under law of cosines. Now, nothing's labeled here. Let's just label this third side as x. That's the distance between the two houses. So what we want to do now is just use the concept of law of cosines. One side squared equals the sum of the other two minus twice the other two times the cosine of the angle across from what we started with. Okay, so we're going to start out with x squared. What would come next in my formula? We've got one side squared equals, Don?
70 squared.
Okay, so 70 squared, we've used this one. What else? Yeah.
Plus 50 squared.
Plus 50 squared. All right, so one side squared equals the sum of the other two minus 2 times what times what? Yeah?
70 times 50.
2 times 70 times 50. Times the cosine of the angle across from the side we started with. What's the angle across from the side we started with? Yeah. 70 degrees. And that's our formula. So we're going to get kind of big numbers, but we just have to type that all in. Let's do what we can first. 7 times 7 is 49, so that's 4,900. Let's see. 5 times 5, that's 25, so that's 2,500. 2 times 50 is 100. 100 times 70, that's 7,000. And I think that that's all we can do without the calculator. All right, so let's do, well, we could add these up actually. Let's add. What's 4,900 and 2,500?
7,400.
7,400. So we could do that. Now remember, don't do 70 times 7,000 times cosine 70. I mean, yeah, that's what you want to do. Don't do 7,400 minus 7,000. You can't do that. All right, so order of operations, let's do 7,000 times cosine 70. That gives me 2,394.14. And I'm not even going to worry about doing this. I'm just going to do the last step right here. How do I get that exponent of 2 to go away? Yeah. Yeah, I'm going to take the square root. So let's just do the square root of that whole thing, and that's our answer. So square root of 7,400 minus 2,394.14. So the distance between the two houses is 70.75 feet. All right, so x is about 70.75 feet. And we use Trig, we stayed safe, we're good, no Easter Bunny, no poisonous tree frogs, no crab type creatures. Who's afraid of Easter Bunny? Oh, okay.
That would be me.
If you knew Trig, you wouldn't have had to be.
Oh, I was afraid of Easter Bunny too. Like,
Really?
I never
Oh
wanted.
my god, you're
my-
the only other person.
My parents would force me to like sit on his lap for the pictures, and I would be like
I'd
crying.
be screaming my head off. I have a picture of my aunt's fridge and I'm like in tears.
Oh.
For some reason,
Why is that
Well,
still
maybe-
in the fridge?
Maybe I'll change the picture. I'll make it something maybe less scary.
let's traumatizing.
I'll get rid of the
So
Easter Bunny.
like, oh
I didn't
my
realize
God.
so many people had like emotional trauma over holidays.
So, homework
Oh my god.
for tonight. Okay, this is the last homework that's in the book. Okay, tomorrow it will be a worksheet. But this is on 274, 9, 11, 13, 17, 25, and 27.
Yeah, growing up, I would tell my parents,